Okay, let's get into this. We're doing a deep dive today on a really specific but high-stakes problem. How do you get pristine, high-quality 4K video from point A to point B when you have to rely on the public internet? The challenge isn't just about speed, it's about integrity.
It's all about integrity. And the piece of tech we're looking at, the Datavideo NVD-40, is built specifically to solve that problem. You can think of it as a translator, a really smart security guard and translator at the end of your stream. It takes a compressed video stream like H.264 or H.265 and turns it back into a physical video output you can actually use.
Right, so our mission here is to unpack how this decoder really delivers on being, as they say, extremely secure and always reliable. And versatile, too. So let's start there. What kind of inputs can this thing handle?
Well, it's designed to handle pretty much all the professional standards you'd expect. So you've got your RTSP, RTMP, HLS, and PEG-TS. But the key thing, I think, is that it can also pull streams directly from platforms like YouTube Live. That makes it incredibly flexible for, corporate workflows or hybrid events where content is coming from all over the place.
And when you get that stream in, what about getting it out? Simultaneous outputs are a huge benefit in a live environment, right?
Oh, absolutely. And all the outputs on the NVD-40 are active at the same time. You get your main high-end output from the HDMI 2.0 port that's pushing out your pristine 4K, but you also get analog outputs, composite video, and RCA stereo audio. That's super handy for fitting it into older systems or just for, simple confidence monitoring.
Okay, so that versatility is fantastic. But like we said, none of it matters if the stream is dropping out. So how does it deliver on that always reliable promise, especially over a shaky internet connection?
This is where we get to the core of the tech. It all comes down to a protocol called Secure Reliable Transport, or SRT.
SRT. Okay, I've heard a lot about this. This is where it gets really interesting
Hmm.
because we usually think of network delivery as a trade-off. It's either reliable but slow, or it's fast but unreliable.
Hmm.
How does SRT get around that?
It's a great question. So think of it like this. Traditional TCP, that's like certified mail. It's guaranteed to get there, but it can be slow because it checks everything. UDP is the opposite. You just, throw the data out there and hope most of it arrives. It's fast, but you lose packets.
Right.
SRT is like having an express courier who's tracking every single packet in real time. If one gets lost or delayed, it's instantly replaced. So you get the speed of UDP, but with the error correction and reliability of TCP, but with much lower latency.
So that's the real-time integrity part. And the S in SRT, that's for secure.
Exactly. The streams use AES encryption end-to-end. So even going over the public internet, your content is locked down. And you can actually configure the error correction. You can basically tell it how much packet loss to expect and compensate for.
Which means you can get broadcast quality over a standard internet connection. That's a game changer. Now, beyond the hardware itself, it also integrates with the DV Cloud platform. How does that simplify things for users?
The power there is really about remote management and simplicity. DV Cloud is like a broker for all your devices. So instead of messing around with IP addresses, copying stream URLs, or fighting with firewalls, you literally just click to connect an encoder to a decoder. It just works. And you can control the decoder from anywhere in the world.
And I imagine the cloud connection is a huge win for distribution, too. It stops the source's internet from becoming a bottleneck, right?
Precisely. If you need to send one camera feed to, say, 5 different locations, your encoder only sends one stream up to the cloud. The cloud then does the heavy lifting and distributes it to all 5 decoders. Your source location's internet connection doesn't get clogged trying to push 5 separate 4K streams.
That's a critical difference for professional live production.
Okay.
One last practical feature I noticed was the real-time video flip and rotate. Seems small, but useful.
Oh, it's great for things like digital signage or just creative camera rigging where a camera might be mounted upside down. The decoder can fix the orientation on the output. No extra gear needed.
So to sum it up for you, the listener, what this technology really does is it fundamentally separates the quality of your video from the quality of the network you're sending it over. It's about guaranteeing that 4K integrity and security no matter what.
And that raises a really interesting question for you to think about. We've seen how real-time error correction, like SRT, can guarantee critical video data. But if you could apply that same level of guaranteed integrity, that same low latency security, to any kind of data being sent across the public internet, what other kinds of high-stakes applications does that unlock? Think beyond video, maybe medical data or industrial control systems. What new possibilities does that kind of reliability open up?